Hi and welcome to DCO. My name is David Capetti, and in this video I'll be sharing how to create this truss system. We'll start with the outer frame, then move on to techniques for creating the inside pattern. Then we do an array in a linear way, and those are the basics of what we'll be going over today. So thank you very much for being here. If you want to support my work and access all of the scripts that I make for this YouTube, check out my website capettidavid.com. When you become a Script Vault member, you can access all of the videos from the past and all of the future videos, and also get in touch with me. I have other resources like being able to learn Grasshopper, Script Store, and a few other free resources on my website, so if you haven't, check it out. Thank you very much for being here, and let's jump right into the tutorial. First thing we'll do is go here inside of a new Rhino file and a new Grasshopper file. I'll type in units and I'll be working with feet. And then here inside of the Grasshopper file, I'll go to new document and I'll make sure to have the draw icons, fancy wires, and names. This way we're both on the same page. Now let's get started with our base geometry, which is going to be a curve or a line segment. To keep it simple for this exercise, let's go ahead and create an arc. So we'll start here by bringing in a XZ plane, which will allow us to change the base grid to an orientation where we can place that arc upright. Otherwise, it's going to be created here on the ground. Let me show you here. Let's go to an arc component. Now let's go here, take the plane input or the output and plug that into the input. And as you can see, let me unplug this. By default, it will create it here in the XY plane. And you can see that when you hover over the input, it's going to say XY. We're going to change that to XZ. And now let's change the radius to a size that's reasonable, nothing too large. We don't want too many subdivisions to start, and we can always change this as we move along. So I'll double click, bring in a slider of 15. So if you just type in 15, it'll give you one from 0 to 100. And now we can plug that in as a radius. So this is going to be our base geometry, and technically this slider is going to be the size of our design. So we'll go here to number slider, change this to structure size. This way we can keep track of what our sliders are doing. Sometimes I go fairly quick when I'm getting in the flow. So it's good to always keep those organized. Now we're going to move on and offset this to create that truss design. So when we have this base curve, well, what we need to do is offset it. So we'll go here to offset curve. And we're going to offset this arc here. So we'll plug that arc into the input here. And when you do an offset, it's going to always ask you for a reference plane. What happens though is when this arc is plugged into the curve, it automatically will give you the same plane that the arc is on. So it kind of references that, but it's a good practice to plug in this plane into the plane input. In this way, it'll use this reference plane as our offset geometry reference plane. So with that being said, let's move on to not just offsetting it by a default of 1, but we'll go here to 1.50. And I also want to offset it to the inside. So what I'll do is I'll take this, copy it down, or we can add another input. I do though like to keep them in a separate component. So we can either go 1.5, bring in a negative component, and now we can plug in this one additionally, so holding down shift, and we can now do it to the outside and to the inside. But I actually like, personally, having two separate components where this bottom one and this top one are going to be offsets from the center, but they're going to be in a different component. Another way of doing this would be to, let me copy this here. We'll do both of the inputs into this one and then go to a list item, plug that in. And since we know we have two curves, we'll have to flatten the input because it's actually bringing in it bringing it in grafted. So we'll have to flatten it here. And then here for the output, we could have two separate outputs for inside of this component. So there's two different ways of doing it. Whichever one you feel comfortable with is the direction you should go. And also these are techniques that may work on one and may not work on the other, and all the way around. So with that being said, I will delete this for now and just use these two as our base offsets. Now what we want to do is take these two and close this into a closed polyline. And so there are two ways of doing that. Technically we can loft this together, but one of the techniques I like to use to close two offset curves is go to the endpoints, which will give us the endpoints of this and this. So we'll plug in the curve into the curve input. We'll do the same thing down here. So I'm sliding it, tapping Alt to make a copy. And now we have the start and end points. Well, we know that when we have points, we can create line segments. So I'll create a line segment between the start and end point. And now I'll tie the start points together, giving us the start point and start point, creating a line segment between the two. Now doing the same, tapping Alt and copying it over, and now creating the line segment for this other side. Now what we need to do is we'll move this stuff to the side. We'll label this structure offset. Now we're going to join them together. So let's go here to join curves. Now we'll move these a little bit down and then plug all of those into the curve input. And so now here at the end, when I hover over the input, it'll say 4 values, which are going to be those 4 lines. And then here under the output, it says 1 closed planar curve, which is great. When we go here now and I middle click and bake, when we select that line, I'll move it over to the side. And this is also a way that you can test or make sure that things are going correctly, right? If I would have selected this and moved it to the side and it was not joined, then I would be worried, because that's one of the things I wanted to do here on the script, is join that curve. But now that it's joined, well, we can take these joined curves and go here to boundary surface, which is going to create a surface with a bounding curve as long as it's planar. And so with this, we can move forward and start creating a little bit more detail and adding a few more things. But this is going to be the most important critical base geometry for creating this design. And so let's move on to adding a few more details. All right, so for this next portion, we're going to offset this curve to the inside and just create an outer frame. And that outer frame will become what supports the inside subdivisions. So let's take this line work and let's offset it. So we'll go to an offset curve, similar to what we did with the original line, and we'll plug this into the curve input, and to the outside, it's offsetting to the outside, which is good. Now we can give it a value. So we'll say 1.50. It's probably a little bit too much. We'll go down like this. And if you wanted to go to the inside, we can also do that. So actually, it's going to be better for it to go to the inside. Otherwise, it's going to go lower than our construction plane here. And I think it's going to be better this way. So negative to the inside. Right now it's at 0, so it's not offsetting it by anything. And then here we'll change the values. So we'll go here to 2. And then 0.2 here. So between this line and this line, now we're going to do something similar with this, but we're going to create the surface between those two. So as long as they're on the same plane, like I mentioned, we can add both of these to the plane to the edges input, and then flatten the input here. Next, we're going to take this, and now we'll extrude it in the Y direction. And one of the ways I guide myself is using this bottom left X, Y, Z coordinate system. We can extrude it here in the Y direction. So we'll go here to extrude. And extrude, you can plug in both surfaces and curves. Unlike in Rhino you have to type in extrude curve or surface. With this one, we can plug it into this one. And now the direction, well, it's not going to do anything unless we tell it what direction. So we'll go to unit Y. And now we'll do this once again, copy this slider over. And so this is the structured frame depth. And this is going to be frame offset. And so if we go back to the start, let's see if everything is still working, and it is. So this is the offset. The outer frame. And the depth of that frame here. Okay, cool. So now that we've created the outer frame, there are different ways to create the inside portion. I'll be going over 2 different ways of doing it. Let's go over some of those. So we'll take this original surface and let's hide it. So right click, disable preview. And what we're going to do is create the segments that go in here using this original curve, so this arc, and we'll be creating one segment and arraying it around this and then moving it halfway. So let's start first by going back to the original arc, and let's also find this line segment that we have here, which was the one that closed the 2 offsets. So with this, we're then going to go to array curve or curve array, and we'll plug in the lines into the geometry, this arc as a curve, and you'll see that it's actually we should do the other side because the curve is the other way around. So this one is the one that will actually work, right? So if we select this is the start, this is the end, it's going to array it this way. If you have it organized all the way around, then it's probably because the way that the arc is created, you have it backwards. So with that, we have the count amount, so we can go here to 15. And this is a way to be able to subdivide it here. Now the only thing is that we have a first and last curve that we don't want. And so to do that, to select all of them except for those, there are a few tricks that we can use here. Let me share with you the way to do this. So if we go here under geometry, let's lower this to like 5. So if we have 5 subdivisions, well, we technically only need 1, 2, and 3, and then the first and last we don't need. So what we need to do is go to select only, not 0, but 1, 2, 3, and then subtract the last one. List item. And since we have 5, we need to pick not the first one, but the second curve, and then subtract the last one. So what I'll do is I'll bring in a series of numbers. The count will go to 5 because we have 5 here, but we can lower that. The step is going to be by 1 because we want a series of numbers stepping by 1 and starting not at 0, but at 1. Then here, we need to plug in that geometry into the list item. then the series into the index. Now we have 5 numbers. We actually want to decrease this to 3. So what we need to do is 5 minus 2. So we actually need to subtract 2 numbers from the total count number. And what this does, so what series does is it'll create a series of numbers starting at 1, which is this one, and then ending 3 numbers later because we have to get rid of 2. And then the count will be 3, and the series of numbers will be 1, 2, and 3, and that selects only the inside ones. And if we increase the count, it'll do the same for all of them. So what happens is we technically just removed the first and last item from this entire list of arrays. And so that is one way that I like to do that, by using basically the data and the numbers that we plugged in to figure out how to basically remove the first and last. Now with this, now we can move into turning this into a pipe. So let's go here to a pipe component. And we'll plug in those curves into the pipe input. And now we'll go caps, flat, and then radius 0.888. So this is going to be call it array number, and then here starting 1, ending, stepping by 1, starting at 1, and stepping or count 2 less than the total. So that's basically the equation of how to remove the first and last when you do an array like this. Now with this, so let's hide most of this stuff. Now with the pipes, now they're all the way out here in the front, which is cool, but what happens is it technically doesn't work because we're all the way to the outside. So we need to move it in the y direction by the same amount as the pipe or more. So we'll just center it. And so let me show you how. Since this was extruded in the y direction by 0.98, then we need to move this in the y direction by half of that. So we'll bring in a move component. We'll move this pipe. In which direction? In the y direction. So it basically moves it to the other side. And then we'll do times 0.5. And we can hide this stuff. Here's the thing. The line segment, all of these line segments here are a little bit too long, so they will go into the outside portion of the frame. So what we need to do is take this and we'll scale it down relative to the center of each. We'll go to scale. We'll bring in a midpoint because to reference the scale, we need it from the center, so it does it equally from each side. So we'll center it and then factor. It has to be smaller than 1 for it to be smaller. We'll go to 0.998. And so now we can select this and plug our geometry in, which is going to be the line work here. And so with this, and even down here, caps, round. Now we can plug that line work into the pipe component. So the pipe component, we unplug from the original, so you can right click here, disconnect this one, and the scaled ones will connect again. What I'm doing is changing the scale of that pipe, and also here changing some of the subdivisions so we can see exactly how that works. I'll disable the preview on most of this stuff except for our final portion. And so that is one way to get the structure working like that, is to take a segment, create it down here, array it, and that will basically take care of the subdivisions here. Now the next one is going to be different, which is creating a circle here and arraying it and seeing what that looks like. And so those will be kind of the two techniques that I'll go over. And then we'll go ahead and take this design and array it. This way you can see what it looks like when you create one basically block of your geometry, and then you can go further and array it and create other things, right? So what I'll do is I'll take most of this stuff that we have here, and I'll just be middle click and disable preview. This way we can work on the rest of the design. So I'll group this also, Control G. And once you get that group, you can kind of see this is going to be the iteration for one of the patterns. Now we'll be creating another iteration for the inside. Let's go to our base arc. And let's go here to divide, curve. We're basically going to be doing the same thing where we select only the first and last. But what we'll do is we'll take these points, we'll bring in a Y for X, Z plane, and place that exactly where those points are. Now we're going to go to a circle component, and we'll use the plane as the input, and the radius is going to be the structure offset. This way it ties it to the outside, but we can also technically make it a little bit smaller. So the radius, we can have its own slider here if we want to. Sometimes the construction planes are a little obnoxious, like they get in the way, so I'll select it, disable the preview, and then in here, well, it actually wouldn't look too bad if we do like half a circle at the beginning and then goes on. This is going to determine our count, so we'll go to 15. Now at this point, well, we have our circles, and we also have this surface up here. What I'm going to do is wherever the surface overlaps with the lines, I'm going to get the line work. So I'll go here to intersect, physical, and then we'll go brep and curve. So it'll be this surface here as the brep input, and the curve is going to be this circle. As you can see, it cuts it here. And so now we can use this and do something similar to what we did here. We'll take the pipe component, I'll copy it down here, or I'll copy it up here, and then use these lines as our curve input, and then preview our stuff here. So let's go here to flatten. What happens is caps are flat here. And here's the other thing that I'm noticing is that actually that may not be the best one to use. What I mean is this surface may not be the best. Why? Because it's the outside. So after that, we had offset it to the inside. And so if I use that, so if I go here to boundary surfaces and create one on the inside frame and use that as my intersecting surface, it actually cuts it off and it basically fixes the issue that we had. So here we have this one, this one. I'm going to bring this over here and let's zoom out and organize this a little bit better. And so by using the intersecting technique, we don't need to do any of the list item things that we did here, where we basically subtract the first and last one. Now all we need to do is intersect those two. So that's a good thing to know. I'll go in here and let's change the array. Next is do what we did here, which is move it halfway in. So I'll copy this here, plug that in, and then preview it. And it's now previewing it in the right location. Let's disable the preview here. And so this is going to be I'll do circle size 2, and then this is going to be size 1 actually. And then here, right click, and then circle size 2. This one is structure scale. And then here under the radius, we're going to then go here to this one and change. So with these two options we have on the inside, I'll disable this so we can see the final portion. So the depth is a little bit too much on this one, and it keeps it right at the center. So two different options. With this one and with the frame, now we can create an array with these two. So that's what we'll be doing with these two. What I'll do is I'll take these top ones, basically the other option, and I'll Control G and group it. Now let's take this and array it in the Y direction. I'll take this, these two, we'll go to a move component, and also a series component. This will let us pick more than one number so we can create an array, and then we need a direction which is going to be in the unit Y to move it in this direction. Now we'll go to the series component, into the factor. The count is going to be how many copies you want to create. So we'll go here to 5. The step amount is how much space in between the two copies. So we'll go here to 15. And starting is going to be, what is it going to have the first gap at? So we'll go to start point 0, it should be fine. And now we can plug in our geometry, so both this one, and plug the Y factor into the motion. And the reason why it creates that many copies is because here at the output we have 1, 2, let's see. We have 5 different values and they go 0, 15, 30, 45, and 60, and that's the copies that it's creating. Now if we want to array other things, the way to do it, to have separate outputs, this way you can put them into different layers, well, we can use this, copy it up. Now we can array, let's say, this design. And let's disable the preview on our original stuff. And we're able to see that, yes, we're arrayed it in the Y direction. There's 15 feet between them. We have 5 of them total. And that's a technique I typically use when I want to array it in a linear way. Now there are other things that we can do, like creating a curve or creating a segment that you can array this through. But the idea for this tutorial is more like the techniques that will allow you to create something like this. And then later on, I will share with you guys other techniques that can let you create more of like not such a linear extrusion, but more of a dynamic design. So with that being said, let's move forward here and let's array. Not just that, but we'll use this one down here as another option. Now what I will do is disable the preview on it, and we'll be keeping it here, and we'll be moving on to the next step. So we've had these 2 iterations. Now I want to hide those because there is one more iteration that I want to show that is actually really cool, and we already have most of the work done for that. The way to do that is we'll go to this surface that we had here, this surface that we had created on the inside, and we want to bring in the circles. Let's decrease the size, and we're going to subtract the circles from the surface. So I'll go here to region, difference, and we'll subtract from the inside surface those circles. As you can see, it creates the outer boundary of that region. So it subtracts the circles. Now we can go to boundary surfaces again. Disable the preview. This and this. When you do region difference and you have a lot of objects, it does sometimes lag a little bit, so just keep that in mind. Cool. So we're here at 0.8, we'll do 0.75. Now we'll extrude that rather than move it. We'll go to extrude in the Y direction. So the surface will extrude in the Y direction. And we'll bring in a slider for the depth of this and move it halfway once again, the same way that all of these are moved to the center. We'll go to this one. So I'll disable it, or take this, copy it up, and then we'll move this portion to the center. But now we have this, and let's disable the preview on this because it's getting in the way. It's halfway through this. Well, let's see here. Oh, this is going to be the array. So before we array it, so sorry about that. Before we array it, we actually move it in the Y direction, half the distance. So we'll plug this motion, this one down here, and it's going to be the Y direction here to the center. Now we can disable the preview on all of this stuff. And now we can array it again. Copy this up. We'll use this input to array through to all of them. So we're just basically copying the array portion of it and arraying it this way. Now these are circles, right? So with the circle, we can create polylines, we can create polygons. And so you don't necessarily just have to stick with circles. We can do any other design. So with that being said, hopefully you found that interesting. I will be doing a render showing you what this looks like at the end. Last thing that I would do is probably create more of a cover structure. It'll be glass for the design that I'll be showing. But yeah, hopefully you found that interesting and useful. Let me know if you have any questions. I'd love to help you through learning more techniques for parametric design.